Today, we will be knowing about industrial robotic arm. With the increasing automation of industrial process and Industries 4.0, we have chosen to focus our project on one of the most important symbols of these ongoing revolutions, the industrial robotic arm. These advanced machineries shows the advancement made in the mechanical engineering, artificial intelligence, and automation technology. Industrial robotic arms have become the backbone of manufacturing and assembly lines for several industries like automotive industries, electronic manufacturing industries, food and beverages, pharmaceuticals, and more. These bring unprecedented precision, speed, and consistency, which are invaluable for maximizing production and minimizing errors.
So, the major motivation behind picking up the robotic arm as an engineering graphics project was the kinematics that a robotic arm has. A robotic arm has a lot of degrees of freedom and it can access any position in the XYZ coordinate. Now, to provide this flexibility and dynamicity, there's also a lot of design aspects that goes into it. Like here, the shoulder-like joint, the pivot joint, the different joints that we saw in the robotic arm was really we could visualize it in an actual model and also see the visualization in AutoCAD while we're assembling those parts. And seeing those movements, we got a better picture that how a robotic arm also functions. This robotic arm could later also be used to actually code the movement in using different softwares later on. So while keeping in mind all the aspects, we also saw that the material selection in robotic arm is quite different. Like for a robotic arm that is gonna be used in the automobile industry, it's very different. So the robotic arm which we have made is kind of, you can scale it to different versions of it. So one can also make 3D printouts of the different parts and assemble it. And also someone could make it at an industrial level using different manufacturing techniques. Hello everyone, my name is Debujit Das and I'll be explaining you the working of a robotic arm and the parts that I have made and the process of making those parts and the challenges I faced. So I was tasked to make the forearm, the upper arm, a part of the shoulder. That was the three components that I mainly contributed to. So coming to the coming to the working of this robotic arm, you can clearly see that the robotic arm is fully flexible and has all the degrees of freedom that was promised in the proposal. Here you can see this is a shoulder joint which can revolve in all directions, 360-degree rotation. Here you have the upper arm, which does not have a 360-degree rotation but can sufficiently move. And here is another degree of freedom. So through all the rotations, it helps us to reach at any positions which it wants to grab. At the end of the robotic arm, we basically have the gripper claw, which actually can grip different parts of any object that is required to pick up. So that is the robotic arm that we actually manufactured. And here you can see that it's totally flexible and can move freely. Now let us come to the main component of the three main components that I worked on. First, coming to the forearm that I collaborated with Devesh to make the part. Here, firstly, what we did was we actually took the very first base of it, made this part, and the middle feature which you see out here is basically made by lofting. And here you can clearly see that this is basically a mirror image. So what we did was that we actually made this part first, then we made the other part here, and then we used the loft command to actually join both the parts. Here there were a cavity that was made to fit the wrist of the robotic arm, and here there were fillets provided to give the actual feel that we require. Next, coming to the upper arm. The upper arm was basically made in two different components because it was not exactly symmetric. As you can clearly see out here, that the upper arm is not symmetric because it has different structure out here and a very different structure out there. And compared to the forearm, which is quite symmetric. Now coming to the upper arm, let's see how it was manufactured. it was designed in two different parts. One was this part, and then there was the other part, which was the part B. So, and both the components are joined. Similarly, like the forearm, this was also made by Lofting. So first we independently made this part, then we independently designed this part, and then we used the loft command to actually loft out here. We use the curvature to give a certain smooth and curved look out here, and the different part and the parts are connected in such a way that the fillets which were provided are continuous. Next, my work on shoulder. In the shoulder, my peer Devi made the entire base, and my challenge was to put this part. So we created two different planes which were actually perpendicular to the edge of this base and the edge of other base. And we first designed this part and extruded in both the ways. And then we provided the fillet of the required radius. The major challenges that we faced in making these parts, firstly, in this part, it was a challenge to actually fit it exactly with the base and have no outer structure that was pointing out. Secondly, it was very important that the distance between this two is kept very precise, so that the upper arm can fit exactly out there. Now coming to the upper arm challenges, the upper arm, it took a long time to figure out how would we loft this part, because and it was also in two different planes. If you see out here, this part is in totally a different plane, and this part is in a very different plane. In the forearm, the challenge was basically out here in the lofting. Here the lofting has a solid curve. So the lofting was made in three different phases. First we used the face out here, then we created an extrude out here, and the other face out here. Then we use all these three faces to create the loft, which provided a very curved and a particular look that was required.
So I am Dakshin, and this is the part that I have made. So basically, this is the connector part, which is an intermediate part of the wrist, and it basically connects the wrist to the forearm, which in turn connects it to the entire robotic arm. This part is also connected to the gripper, so it is also responsible for all kinds of actions like moving up and down on deploying and all that. Now I will briefly explain to you how I made this part. So first of all, I made a 1/4 cylinder type, hollow solid cylinder type. Then I hollowed it out to the length and left some of the thickness there. After that, for the bottom of the bottom base of the part, this is the kind of design or sketch I have made, and which is then extruded out. Next is also one of these design sketches that has been extruded out, as you can see. So next is the parabola that I have traced. So a parabola was used in making. So a parabola, as you can see, parabola was traced using the equations, and then it is also extruded out. Next is the trapezium kind of structure, which first I made a plane, which is directly perpendicular to the curved surface, and then the trapezium sketch was made, and then it was revolved for an angle of 14.3 degrees, as you can see in the image. Then after completing all of this, this 1/4 part was basically mirrored. So this small 1/4 part was mirrored from the XZ plane to get this next half. And this half was then mirrored on the YZ plane to get the complete structure, which is this. So thank you very much.
I'm Dipanjali Kumari, and I have been provided with the three major parts of this robotic arm, that is the base, and then connector plate between wrist 1 and 2, and a stepper motor arm coupler, which has been fitted inside this part. So coming to the base part, first we have made this circular arc, and then we have extruded it, and then we have made this flat part of this circular part, and then we have made this part circular, and then we have extruded it with the appropriate dimension. Then we have taken a revolve geometry with the center, we have revolved it and made these seven groups, and same with these smaller groups, we have made at appropriate dimensions and distance, and then we have extruded it this final part, that is the circular part. Coming to the challenges, the major challenges we faced in this part is the dimensioning of this groups, as this part will be fitted inside a shoulder part. So it was a challenging to make it appropriate dimension. Then coming to the connector plate part, for this, first we have made this circular part and then made this a rectangular part and then extruded it. Then we have extruded these parts and then made this hole, and with a circular geometry, we have made 8 holes. The major challenges faced was to make at appropriate arc and at appropriate angle of these holes, which was a difficult task. And then coming to the stepper motor part, first we have made the circular part of different dimensions and this circular part of different dimensions, and then we have made this hole by taking the plane and then these groups of appropriate angle, as these groups are of different angle and of different sizes, so we have to vary it according to that. The major challenges was to make these groups at appropriate angle, as the groups are located at different angles from each hole. So that was.
Hello, I am Divya Chudasama. My major contribution was in making the shoulder part of the robotic arm.
Hi, I am Devesh, and my major contribution was in creating the forearm of the robotic arm. And till now, we have covered all the major parts, and this is the wrist part of the robotic arm. This may look simple, but this consists of many other sub parts which are created by our team members who are not available today. So the wrist consists of sub parts like gripper claw, base plate for gripper claw, and other plate connectors.
These parts actually may look simple, but they have their own complexities in terms of its dimension. The dimension of these subparts is very crucial for the well functioning of the wrist in overall. Since these parts assemble one after other, the dimension need to be very accurate so that they can function properly and simultaneously.